Welcome to this session on Cloud SQL for MySQL. We realize it is a tough time. I hope you folks have had time for lunch, and we'll try to keep you awake. We have a lot of content to cover, a lot of interesting content to cover. I hope you're having a great time at Cloud Next. As most of you are aware, MySQL is a widely popular database, kind of an older open source database. And we know a lot of you are running large fleets of MySQL. DB-Engine's ranking says that MySQL is the second most popular database. And who doesn't like a cute dolphin? What do you say? So with that, I'm excited to be able to talk about Cloud SQL for MySQL and all the latest innovations that we have added to this service. My name is Sujatha Mandava, and I lead the product for Cloud SQL. And we'll talk about Cloud SQL a little bit along with MySQL. I am joined by Jeff Sosa, who's sitting right here. He's the product manager for MySQL. And also Phani Mullapudi, who is the principal SRE from Palo Alto Networks, who's a GCP customer as well as a Cloud SQL customer. Quick look at the agenda. I'll start off by giving you an overview of Cloud SQL, all the services it manages, the operational burden that it reduces for you. I will give you an introduction into Enterprise Plus. This is the latest launch that we had a little more than a month ago, Cloud SQL Enterprise Plus that gives you improved performance and availability capabilities. Jeff Sosa will dig deeper into these capabilities, showing you some performance benchmarks and how we're achieving this. Finally, we'll end with Phani, and please don't miss this because this is extremely interesting, where Phani is going to walk through Palo Alto's network's journey from self-managed MySQL to Cloud SQL for MySQL. So definitely a lot of content here. Finally, we will have Q&A, so we hope to carve out some time. There's a mic up front here. You can walk over to the mic and ask us questions. Or if we don't have enough time at the end, Jeff and I and Phani will hang out, and you guys can come forward and ask us questions. So really looking forward to presenting to you. So let's do a quick overview of Cloud SQL. Cloud SQL is a fully managed service for 3 engines: the open source MySQL, open source Postgres, as well as Microsoft SQL Server. What does fully managed mean? Cloud SQL makes it extremely easy to set up, install, and operate, and scale. With just a few clicks, you can actually create a highly available instance. You can create multi-regional backups so that if you have a global application and that's needed, you can also create replicas so that you can scale your reads across regions. No more managing infrastructure, database versions, upgrades, also worrying about scaling issues as your application grows. When it comes to security, I think having a trusted platform is extremely important. So Cloud SQL makes it easy to track, control, review what data access your users have by using tools like IAM authentication. It has database audit. It supports access transparency, justification, and many, many more features. On the developer front, extremely important persona for us. With an API-first approach, we are able to have users quickly deploy and configure at scale. With the observability features, the insights that we provide, we are able to provide app-specific troubleshooting, performance tuning that are actually important for you to be able to run available applications. It is one of the fastest growing services in GCP. We are excited that more than 95% of the top 100 GCP customers use Cloud SQL. And with that, I have a quick question for the audience. How many of you already are customers of Cloud SQL? Awesome. That's really good to hear. Awesome. Thank you. And so we really thank you for your support. And for the folks who haven't tried out Cloud SQL, I have just a quick slide on the benefits of what the managed service Cloud SQL provides. Cloud SQL provides the best TCO so that you have capabilities like performance, scale, availability, security, governance out of the box. you are able to reduce costs, reduce your operational burden, so you can focus on innovating with the applications themselves. Focus on the application rather than running a managed service and all the different tasks that you see that includes running a managed service. So we make it extremely easy for you to be able to innovate on your applications. So what did we hear from you as you started deploying? We have feedback from you that you need a destination for your most critical, business-critical workloads. And there were 3 aspects that came out. You wanted higher performance for these workloads, higher read and write performance. You wanted higher availability, both in terms of SLAs, as well as reducing the downtime for maintenance events. And finally, having extended data protection for your business-critical workloads. Based on this feedback, we, in July, launched Cloud SQL Enterprise Plus. The existing Cloud SQL stays the same. No change in features, no change in pricing, just a new offering called Cloud SQL Enterprise Plus. Cloud SQL Enterprise Plus has benefits in 2 areas, and I'll dig a little deeper into this. Performance, as well as business continuity. In performance, we now have better compute and memory options. What does that mean? We have higher memory ratios for CPU to memory. We actually use the latest processor family. And finally, based on the underlying hardware, we have actually made software optimizations to improve the performance on this box. And one more thing, we do have an optional data cache that actually speeds up your most accessed data, thereby reducing the latency for reads. With all of these improvements, we are now getting, based on our internal benchmarks, 3x the read performance compared to the existing Cloud SQL offering. The existing Cloud SQL offering is now called Cloud SQL Enterprise, and the new offering is called Cloud SQL Enterprise Plus. Now let's talk a little bit about the availability. And Jeff will do a demo demonstrating some of these capabilities on availability. But we want to talk about 4 nines of SLA. So we actually have, with Cloud SQL Enterprise Plus, 4 nines of SLA, including maintenance. We also have less than 10 seconds of maintenance downtime. If you are an existing Cloud SQL user, you know that the current maintenance downtime is less than 60 seconds. So it's a huge improvement over the current Cloud SQL Enterprise. You get a less than 10 seconds of maintenance downtime, and you'll watch a demo talking about that. And on the business continuity side, the last thing I wanted to add was log retention. We now support 35-day log retention and hence 35-day PITR, a kind of an important requirement for your regulated industries, as well as you folks know, your SaaS customers, this is your contractual obligation to your end users as well. So 2 aspects, superior performance, enhanced availability, extended data protection. That's what Cloud SQL Enterprise Plus entails. How many of you, before I go into the next slide, have tried Cloud SQL Enterprise Plus? We have to change that. We definitely invite you to come and try out Cloud SQL Enterprise Plus. Give us feedback. We are seeing a lot of interest from customers, and we'd love to hear from you how well that testing is going. All right, with that, I want to get to my last slide, which is essentially partner ecosystem. You know that building applications is not just about databases. It's being able to think beyond the databases. That's why we've been working with an ecosystem of partners. You can see that the partners are in different categories, whether it's observability, whether it's migration partners, whether it's analytics partners, security partners, and many more. We're working with these ecosystem of partners to be able to test compatibility, to fine-tune some of the functionality, and also optimize the integrations so you spend less time on making sure the applications work. This really reduces your time and the costs that are required to certify these applications and make them work well for Cloud SQL. As you can see here, this is a program that's been launched, and we hope to be adding more partners over time. With that, I am actually going to hand it over to Jeff to talk a little bit more about the performance and the availability features of Enterprise Plus.
Thanks, Sujatha. Hey, everybody. All right, yeah, so I'm going to dig into the availability and performance improvements in Enterprise Plus in a little more detail. So first, let's talk about availability. We've made several availability enhancements in Enterprise Plus that really help you to maximize your business continuity when you're running your MySQL applications. And the first one that I want to highlight is the 4 nines SLA. So this is up from 3.5 nines that we offer in the Enterprise Edition. And it's a really class-leading SLA for this kind of product. And it's also, the other bonus is that there's no more maintenance carve-out. So the maintenance, any outage due to maintenance, that's on us, right? And it counts against the SLA, unlike the Enterprise Edition. So that's really important. The reason we can actually eliminate the maintenance carve-out is because we can now do what we're calling near zero downtime maintenance upgrades. So Sujatha already mentioned, we can now do a maintenance or upgrade a patch in under 10 seconds, basically, single-digit seconds. So that allows us to offer that SLA without the maintenance carve-out, maximizing your business continuity. And then also, Sujatha just mentioned, we've extended the retention for point-in-time recovery out to 35 days as well. And this little graph is just showing comparing the downtime between, say, the Enterprise Edition and the Enterprise Plus Edition when we do patching. It could have been up to 60 seconds with the Enterprise Edition, and now you can see it's in single-digit seconds in Enterprise Plus. Now I'm just going to run through a quick demo that shows this upgrade timing. And it's a video, and I'm going to play it in a minute, but let me just set it up. So what you're going to see here is we've got a Enterprise Plus instance that's provisioned, sitting there. It's configured for high availability. We're going to run a client, which is effectively this shell on the right, where it's going to connect and retrieve a timestamp from the instance, basically in a loop over and over again, right? So you can see that the instance is healthy. It's responding to requests. Then in the middle, we're going to apply a patch. And you'll see in the console, we're going to go and tell it to update the instance, and then you'll start seeing some errors on the right while the patch is being applied, and then it'll recover again. And you'll be able to see how much time it actually took. So that's effectively what your application would see. So I'm going to go ahead and play it. And I'll try to talk through while it's going. So here's your mighty instance, Enterprise Plus instance, ready to take on your workload. You can see here we're highlighting in the attributes that it's Enterprise Plus Edition and that it's configured for high availability. And then on the right, we're going to run this script. And like I said, it's going to connect, get this timestamp, and then just keep doing this in a loop. And you'll see the output of it when we run it. So there you go. Instance is up and running. It's responding to requests. The world is happy, right? Now we're going to apply a patch update over on the left in our console. And here you can see we have to add in the instance details. And then we're going to fast forward a little bit because it takes a while till you have the outage, right? So we're going to fast forward to the point where we actually start seeing the interruption. And there you go. OK, so all of a sudden now we're getting some failures. The instance is busy getting updated, but it recovers pretty fast. So you can see it's a total of about 8 seconds in the demo. So that's why we call it near zero downtime updates. There's still a few seconds outage, but your application can reconnect right away. All right. Now I'm going to turn attention to performance. And we've made a ton of performance improvements in Enterprise Plus, and we made some very specific things also for MySQL in particular I'm going to talk about. The performance improvements come from several areas of changes that we've made in Enterprise Plus. And the foundational piece is we're running on a new instance platform that we didn't support before. It's a performance-optimized instance. It's got the latest CPU technology, and it has a higher memory ratio. So now you can get to an 8-to-1 memory ratio, 8 gigabytes of memory per every vCPU. So that in and of itself is going to improve performance right out of the box, just having a more powerful platform running underneath us. For any kind of workload, read, write, or mixed. In addition, there's software changes we've made on top. So some of the software changes are optimizations or tuning we've done to leverage the new platform more effectively. Other changes are just optimizations in either in our I/O path or in other areas of the product. And then finally, for MySQL, we have an optional data cache product that further accelerates reads. And I'm going to go into more detail on that in the subsequent slides. So let's just look at write performance initially. We're seeing some pretty dramatic improvements in write performance with Enterprise Plus because of a combination of a couple of things I talked about on the slide before. So first is this new instance platform. A lot more horsepower available now for us. Also, we've made optimizations in the software, like I said, to tune. And then in particular for MySQL, we've made a bunch of optimizations in the log commit path to really cut down on commit latencies. And as a result, we're getting about double the write throughput in some of these benchmarks. And you get an inverse benefit on latency like you would expect. So we're about half the latency on a commit in these cases as a result of all these changes. So some pretty dramatic improvement in write performance. We run these, the benchmark we're running is Sysbench, pretty standard, off-the-shelf benchmark. And a lot of our customers have tested Enterprise Plus themselves and run their own benchmarks, and they've proven out the same results as well. So that's write performance. Big improvement, up to 2x more throughput, half the latency typically for commit latency. And then on read, in particular, so read performance is improved just from the new instance platform and the tuning and the other optimizations we've made, similar to write performance, right? You do get read performance boost just from that. But for MySQL, we've added another extra capability on top to further boost read performance, and that's called data cache. So when you enable data cache, you can get up to 3 times the throughput for reads on MySQL workloads. And again, running the same benchmarks, it's the standard Sysbench benchmarks. Very easy to reproduce this. I'll talk more about data cache and how it works on the next slide. But what data cache does is it allows us to start leveraging flash memory in an instance as a caching layer, in addition to just having memory. So that's the big difference. But I'll talk a little more about how we use it on the next slide. So again, dramatic improvement in read performance. This is really class-leading performance for a product like this. All right, let's talk about the data cache. So it's an optional feature in Enterprise Plus that you can enable only for MySQL today. And what we're doing, I talked about how we leverage flash memory now as a caching layer in addition to your main memory. Typically with MySQL, you're gonna get the best performance, obviously, if, say, your entire working set is in memory, right? And you don't ever have to go out to instance storage because you're gonna incur latency doing that. Well, what we've done is we're using this locally attached flash memory as more of a middle tier cache now. So it effectively expands the amount of local media that you can store your buffer pool on. So with MySQL, typically what you're doing is you have a buffer pool that fits in memory, and that's where a lot of the query results get serviced out of if possible, and if not, you have to go to disk. What we're doing is extending the buffer pool to actually leverage a local SSD in the instance. So we call it internally a buffer pool extension. This is unique to Cloud SQL for MySQL. And what we're also doing is when we service a query, we have metadata that effectively can address all the data that's in either level of cache. So we automatically know where to find the data to service a query, whether it's in memory, whether it's on the local SSD, so we can instantly just retrieve it. So this is gonna work best if you do have a working set that is larger than the memory in the instance. So that brings maybe some other possibilities, right? When you think about how to provision, sizing, et cetera. We've got a lot of customers who are over-provisioned maybe on compute because they were trying to grow a big memory footprint to host all their data. Well, maybe you have other choices now. You don't have to over-provision compute as much maybe. You can have maybe a smaller instance, but you can leverage this data cache and still get good performance for reads. So these are some things that now other options now customers can start considering, balancing price performance when provisioning Cloud SQL, or provisioning for MySQL in the cloud in general. A couple other details about how this is used. It's very simple as far as the user is concerned. You just turn it on or off. That's it. We don't have knobs and things to adjust, anything like that. You just turn it on. We manage it automatically for you. And what we're doing is we're provisioning a fixed size of local SSD based on the size of the instance when you do enable this. And yeah, I think I covered everything on this. Again, it's manually enabled and disabled at any point. You don't have to decide you want to use it when you're creating or provisioning the instance up front. You can have an instance sitting there and then later decide you're going to turn this on or turn this off. So, all right. And I've also listed on the slide what sizes that we actually provision for this based on the number of vCPUs in the right-hand column. So, which you can also find in all of our documentation, obviously. So, all right, and then so those are the big improvements in Enterprise Plus for MySQL that I wanted to highlight and make everybody aware of. Like I said, we have a bunch of customers that are using this already and are instantly seeing the benefits. Again, it's opening up new possibilities when it comes to provisioning for price performance, as well as business continuity and availability. So I encourage everybody, if you're a MySQL user, check it out. But beyond Enterprise Plus, we have other enhancements we've made to Cloud SQL for MySQL over the past, say, 6 months that I just wanted to highlight. So these are things that are available for both Enterprise Edition as well as Enterprise Plus Edition. First one is we now support up to 500K tables. We've got a bunch of customers that are pushing those kinds of limits with the table counts that they have to support in an instance. So we've rolled out support for that. Doesn't affect your SLA. There's no user surface, there's no user controls for it. It's just there. We do have some operational recommendations as far as instance sizing, et cetera, that we document. So if you're going to scale to that level, pay attention to that to get at least the best experience. And then also, a lot of work has been done on migration for MySQL. And I'm super thrilled about this because it's just making it much easier for people to adopt the product. So the first thing I want to highlight is our database migration service has added a large amount of acceleration for migrating MySQL workloads. And so if you tried to use, say, our database migration service to migrate a MySQL workload, say, 6 months ago, and then you tried it now, it should be about 4 times faster now to migrate the data. So huge improvement. It's providing a ton of benefit. And then we have some customers with just really, really large databases. So database migration service, it does a logical migration, but it's very automated and easy to use. So you point to the old instance, it migrates, it creates this other instance, and it migrates all your data, and then you can promote and switch over at the end. But what we've also now rolled out support for is Percona Extra Backup-based migration for MySQL. And this is in preview right now. This is a physical migration. So in this case, what you would do is you do a backup with Percona Extra Backup. You put your backup files in a bucket. And then what we'll do is create the instance from that bucket for you. And that is, I call it a physical migration because we're taking these database files basically and importing them and ingesting them for you. But that's even 3 times faster than a logical-based migration with database migration service for really large databases. And actually, we have a customer here who's, Phani is going to talk next. They fall in that category where they have databases big enough where they want to try using extra backup as well. Okay, so a lot of improvements on migration for MySQL. We have a really full toolkit now if you want to migrate to Cloud SQL for MySQL. And then finally, some other items that I put under the flexibility category. One is we added support for over 100 new MySQL database flags, which will make it easier for you to migrate, and then also allow you to control some things like replication and performance, et cetera, et cetera. And then finally, we also store recovery logs for the point-in-time recovery feature. We can store them now in GCS. So this helps you to balance your cost because we're not using the instance storage anymore. We can put them out in a bucket and also free up more of your instance storage for your data. So, all right. So that wraps up my section. And now I'm going to turn it over to Phani for the best part of the whole presentation. This is one of our customers, and he's been migrating to Cloud SQL at Palo Alto Networks, and we've been working with him really close, and he's going to tell you all about his journey and what he's been up to. Here you go, Phani.
Sure. Thank you, Jeff. I think Sujatha and Jeff made you to keep awake after the lunch. I know it's not a great time to do this presentation, but I'll also try to keep you awake. So I work for Palo Alto Networks as a principal SRE. I hope you guys know Palo Alto Networks is a cybersecurity leader. I primarily work in the threat prevention and malware detection team as a principal SRE, and we do have a lot of footprint in GCP, especially. We have thousands of database clusters, which runs on MySQL with various versions and all that stuff. We have, with the self-managed running on CentOS, Ubuntu, and whatnot, in CentOS 6 or CentOS 8, Ubuntu 10 to various other versions. So I joined Palo Alto like a year back and was surprised to see these guys are running thousands of clusters, self-managed, with a very short footprint of DBS, and a couple of, I don't want to give the head count, but it's very, very minimal. If you have running 1,000 clusters, you need an army of DBS and all that stuff. So that's where we started. Okay, so this is not, running a databases on a VM is not a right business if you have to scale further and you have to be much smarter. That's how we started. And even if you look at the regions and all that stuff, we are in like 15 regions and we are all over the world. Palo Alto is all over the world. They have like in Qatar, everywhere, and all that stuff. And our average database size is 2 terabytes in average. That's a least size, actually. I shouldn't say average, it's least size. And we are extremely write intensive. We actually sometimes saturate the disk. If you look at IOPS of the disk, we do saturate many times and all that stuff. And we write a lot of data every time. And sometimes it was pretty hard to convince engineering to even do a retention SLA. You get like a terabyte of data every day and you cannot truncate. You can imagine what kind of challenge we could run into. So these are an overview of how a database looks like. And we do present on both cloud and data center. We have some data centers we are trying to migrate to GCP. It's a lot of combination there. And coming to our infra challenges, when you run your self-managed, we have problems of HA and DR. We don't have a very concrete HA and DR. To be very honest, we do DNS failures, which is not pretty smart. So when a primary node goes down, we have to flip the DNS change and tell the application to go through that DNS change from, instead of going to primary node, go to secondary node. So that manual DNS changes is pretty painful, not pretty smart too. And when you run a VM, it's known that if somebody's thinking the VM is going to run continuously, it's not true. VM is meant to crash, or VM is meant to reboot for patches or whatever it is. When hypervisor, undervisor hyper has some kind of maintenance, the VM restart. That's how any cloud works. So we have VM crashes, VM reboots, and all that stuff. So this makes a business goes down, and we are out of business for like few minutes of that outage and all that stuff. And we do have some chances of application data loss and all that stuff. We do handle it from application level, but when instance goes down, it has some kind of degree of impact. And growth and scalability, as I explained, we're extremely write intensive. We saturate this many times. Again, just repeating the no retention policy, and we do actually we end up in increasing our disks almost once in a week. And imagine the thousands of nodes and 15s of regions, and unless we automate it, we get like the disk is reaching your 89% or 190%, we go and increase it. Though we do some automation around it, but we keep increasing it and all that stuff. No auto-scaling, typically when I say no auto-scaling, when there is a lot of read surge on certain days, when there is during a Christmas time or during some kind of promotion going or whatever it is. We don't scale our instances based on the read throughput and all that stuff. It stays same. We have to either bring it back, bring down, upgrade instance, or do something else, or add another read node. So that's all pretty manual. And when coming to the standardization and auto upgrades, we possibly used. I used to make fun with my managers that we possibly used every possible replication topology. It can be Galera, it could be multi-node, multi-write primaries, or chain-based replication, circuit-based replication. We did all kind of possibilities. That's how it's been built. So we have this all mix and match of multiple use cases. We have multiple MySQL versions starting from 5.5. You can imagine 5.5 is dead long back to 8.0 and all that stuff. And the reason we are still on 5.5 is we couldn't get downtime approved from customers or engineering teams because they're not ready to take an outage and all that stuff. And footprint has been said. It's spread over data centers, spread over cloud. We hop between data centers and cloud. We replicate between data centers and cloud because of use cases and all that stuff. So that's how our infra challenges are. And again, last not least, in the Linux versions, we have CentOS 6, CentOS 7, CentOS 8, Ubuntu 10. And the configuration is not same. For example, open file limits in Ubuntu is somewhere else versus somewhere else in CentOS, and people don't even ignore it. We ran into open file limits. People didn't even care about open file limits of 65,000, 536. They set it out. Somebody set it out 1024, and we end up in crashing because they didn't look at the right file. So this all kind of things, and when you run a different OS, you have to look at different places, different configs, and all that stuff. So, and then other things we're talking about, we had, when we wanted to start considering Cloud SQL, we ran into a couple of challenges, and that's how the Persona came into, because every database size is spanned over a 2 terabyte. And you can imagine taking a SQL dump of a 2 terabyte and importing. 2 terabyte would take, I don't know, it would take a couple of days, I don't know, and it would take 3 times of this. The import is 3 times slower than your export. And you can have thousands of such nodes. We have to migrate multiple shards, multiple regions, and all this stuff. It's not practical. So we told, okay, the traditional SQL dump would not work, because that's not how we scale up. And most of the services need zero downtime. And so for example, assuming we still take some kind of dump, runs for multiple days and all that stuff, and they need zero downtime or near zero downtime. We can convince them for a few minutes and all that stuff, because they're moving to a new cloud provider or something like Cloud SQL. And the multi-node replication, multi-source replication, and multiple primaries and all that stuff made things more complicated. Before I go, so another thing was, even if we take a SQL dump for a couple of days, we cannot store the binary logs for such a long time because we write a terabyte every day, and you can imagine if you have to hold a terabyte of binary logs and apply the binary logs after migration, is not going to happen. So we generally don't. Our retention of binary logs is a couple of days and all that stuff. So you have to take an export which runs for over a week, and import runs for another week or plus. We cannot hold that many binary logs. So we thought, okay, a traditional MySQL wouldn't work, and that's how we came into Persona Extra Backup, because Persona Extra Backup is our go-to solution, and that's how we take backups. Coming to the, so why did we start considering Cloud SQL? Obviously, the fast migration is the first thing which we worked with Jeff and Sujatha. A critical success factor of this project is how quickly can we migrate our services without impacting and all that stuff. So that's where the extra backup did come into picture. And high availability. We don't want to deal outages using DNS changes and all that stuff. And obviously, we want the cloud, the GCP to handle that outages and all that stuff. And the high performance, high performance when coming into localized data cache SSD, that's what I was saying, the localized memory, which is nothing but an SSD internally, which can give you more read throughput, more write throughput. And apparently, we even want to decrease the footprint. When I say how does a faster instance can give it a low decreasing footprint is when you're running an instance which is giving you 1,000 IOPS, you need 10 instances if you need 10,000 IOPS. And when you have a SSD which will give 100,000 IOPS, we can possibly consolidate into a smaller footprint, maybe a bigger instance. Instead of running 10 servers, I would run 1 server or 5 servers. So we wanted to even go back and sell that to engineering. Okay, you don't need 10 servers now because your throughput is pretty high. We can consolidate all your database in single thing. Maybe logical database could be different. You can have shard 1, shard 2, shard 3. You don't need to have 10 servers for that, and because you're giving a lot of throughput and all that stuff. So that's one other point. You can think of consolidating your footprint because you're giving better throughut. And upgrade management. As I said, we have every possible MySQL version, and we get into end of life issues and all that stuff. We end up in we ran multiple EOLs for a lot of MySQL versions, and getting them convinced to run a version upgrade itself is a lot of pain. So that's another thing which pain is going to take off when we go to cloud. And I think that's what I have.
On stage. I just had one question for Phani, and then we'll open it up for questions. What do you think, and this is probably for Jeff and Phani since you guys have been working together, what do you think actually worked as part of this collaboration? What are some learnings? What worked well? Anything you want to share?
I think we start talking with Google almost every week, bringing our use case. The collaboration with Google was almost every week. And they including us with the engineering directly and taking the requirements. Like, for example, the Percon extra backup is a clear example of collaboration because that was one of the I was being saying that's a critical success factor for the product to go. And you guys are able to deliver, and that happened through giving us a requirement. You guys are delivering it on thing, and we are able to test it out even during a preview mode. Itself is it's a pretty good thing. That's what I really appreciated. Yeah.
Awesome. Jeff, anything to share?
Yeah, when there's a really complex situation like this, we found that direct communication with the customer on a regular basis really makes a difference because we can take the requirements if they come up where there's might be a gap or something and try to address them pretty quick and answer a lot of questions. I think that's the other key thing is sometimes there's just questions that you guys have about how do I do this, how do I do that, and we can answer pretty quick. So we try to at least be really responsive. I think that's helped a lot.
Cool. So thank you again for sharing
for
your, I think, learnings from this, as well as hopefully that was useful to the audience. I just have a couple of more slides, and then I'll, we'll take some questions. So some more sessions. Some of them are finished, but some of them tomorrow we have a SQL Server session. We have a best practices for Cloud SQL. We have some DMS sessions later on today. I apologize if I didn't add it, but definitely please attend those sessions and provide us feedback. Feedback is always appreciated. Anything on features, presentation, we would really appreciate that.